of C. This is you are familiar with this expression, but you are familiar like equation equal to 0. No. This is like a function, no? Entonces, when you put equal to 0, well, entonces you find another thing. But in this case, this is the name of this way or this form is standard. This is the standard. And the standard A, B, and C in general, A, B, and C are real number. In general. It's important to say que no 0A. So si A is missing, is no quadratic function, is linear function. So the importance of A is extremely important. Okay, this is standard. Good. But we have another way to express the same idea. Okay, it's something like that. A parenthesis x minus h squared plus k. And this is called vertex form. And vertex, this is extremely important point in the parabola, in the quadratic function, because vertex is the turning point. So this point is a vertex. In this case, I put in 0,0, but not always is in 0,0. And the vertex is a point. Is located at the point h, k. So this h and this k represent the component of the vertex point. Que is, I repeat again, is the turning point. Suppose another scenario, que is a parabola like that. This is the vertex. This is h. H represent the x component, and k represent the y component. Okay, this is a vertex. Entonces, another fantastic way to represent the quadratic function is using the vertex form or standard form. Entonces, this form has advantage and disadvantage that we can see in the example. Okay, now one more thing important I need to say at the beginning is this A is exactly the same, this A. There are coincidences in between. And A is important because A, the sign of A, see, A is positive. The parabola open up. And si A is negative, the parabola open down. So the control in what direction open the parabola is given by A. A is the same coefficients in both form, vertex or standard, is the same parameter. A. BC we have here, we have no BC, we have HK, okay, H and K are the vertex point, no? And the control in what direction open the parabola is given by A. Okay, super, any question? Okay, let's move on directly to example. In the example, you can see very, very clear. I bring 3 examples. Okay, in this example, we summarize very, very, very well everything. Okay, I understand. Just disagree with you. A ver. What's the problem, Frank? Activate the microphone. Disagree with me what?
Over the situation with Alex, but that's not what I was trying to discuss. I was asking you about the YouTube subscription, the extra credit points.
Yeah. But what's your question? O sea, you have 5 extra points in any test. So you subscribe in my channel. I have a list of the students que subscribe in my channel.
Okay, so I subscribed, but I never got confirmation. I just want to know if I'm on the list.
No. Hello. You want to I do more job? I have 4 classes. No. No confirmation.
I'm not asking you to do more job. I sent you a screenshot with everything of me subscribed. I'm just asking. That's it. I send it to you in an email so you wouldn't have to do it in class.
Okay. What's the problem?
I just want to know if I'm on that list, if I'm getting the extra 5 points or not.
Let me see. Let me check it out.
You don't have to do it now. You could do it at a later time. I understand you're doing your class right now.
Okay. Okay, I want the thing, we have limited time. The thing we need to discuss in here is mathematics.
Okay, I'm not asking you to discuss it here, sir. I emailed you about it.
Okay,
for that specific reason.
I remember. Okay, don't worry. If you subscribe, I receive notification and you have 5 points. But I don't grade yet.
Okay, but I need confirmation. That's all.
I don't need to do that. This is not my duty. Okay?
Okay.
You trust to me. I am super organized teacher.
Okay, I'm a super organized student.
Okay. Okay, f of x. Let me see exact is the first example. Example 1 is minus 2 x minus 1 square plus a. And what's the question? The question is, bueno, analyze and do the graph of this parabola, ¿no? Es a quadratic function. I realize que this is expressed in vertex form. See, because we compare, no? Vertex form. Vector form. The vertex form, I can see que A is negative 2. We compare, look, A paréntesis x minus h squared plus k, ¿no? H is 1, positive 1. Ooh, be careful, because the value of the h is opposite to the, you see in the equation, you see negative because the original equation has a minus here, right? You see h is positive 1, does it stay negative, right? Si es negative 1, does it double negative become positive, but it's not the case. And k is 8. Okay, entonces be careful. H is opposite sign, value and the equation, and k no. K is the same. Entonces I can see or I can visualize que the vertex point, es lo que at the point 1,8. 1,8. Okay, this is the turning point. And also, A is negative. That means que the parabola open down. Open down. The parabola open down. Okay. Okay. One more thing we need. Well, we need to know, for example, this is important point, y and z. Y and z is the important point, y and z. So what is the formula to find the y and z point? In function notation, you evaluate in 0. When you evaluate in 0, the value that you get is the y and z. So it's minus 2, 0 minus 1 square, plugging in 0 here, replace, plus 8. Entonces es 0 minus 1 es negative 1, pero square es positive 1. Entonces minus 2 plus 8 es 6. Confirmation, the point is the point 0,6. This is the y and z. Because I assume to find the y and z, que x is 0, look at that. And the y value is 6. The point is 0,6. I can plot this point at least. To find the x and z, que is super important, fundamental point, the formula is f of x equals 0. Guys, keep in mind this. Y and z, f and 0. X and z is f of x equal to 0. This is the formula for finding x and y and z. We're using in the entire subject. Not always in this function, in any function. Okay, so you set out the equation, que es minus 2, parenthesis x minus 1, square plus a. Because in this moment, you are in front of the quadratic equation, no? And the super easy way to solve this quadratic equation is, let me see one thing. Okay, somebody record. Wow, fantastic student I have. Okay, let me try to solve it. It's easy. I move a to the other side. So minus 8 is equal to minus 2 x minus 1 squared divided by negative 2 both sides. Therefore, is x minus 1 squared, and apply square root both sides. Entonces we have x minus 1. Let me continue here. We have x minus 1 because the square and square root cancel out each other. And square root 4 is 2, no? Pero plus and minus. Don't forget double sign, plus and minus. Entonces 1, x is equal plus and minus 2 plus 1. So x is equal 2 plus 1. So using the positive sign, que es 3. And another x is minus 2 plus 1, que es negative 1. So basically, we have 2 points. The point are 3, 0. Remember, it's on the x-axis, in which you suppose that the y component is 0, the 3, 0, and negative 1, 0. This is my collection of the x-intercept. That not always happen, but in this case, we happen that we have 2 x-intercepts. And in this moment, we have 1 point, que es the vertex, 1 point, 2 point, que es the y-intercept, and 4 point, que es the x-intercept. Total 4 points. But we need more. We need more to define at least 5 points in the parabola. Okay, so one important thing in the parabola is the axis of symmetry. Okay, axis of symmetry. Okay, one important thing in the parabola is the axis of symmetry. What is that? Well, this is easy. You have a parabola, for example, here, and we have one vertical line that split the parabola in 2 equal parts. And this is axis of symmetry. So it's a vertical line, always. In this case, is x equals something, and x equal h. X equal h, okay, in our example, in our specific example, h is equal 1, look at that. Entonces, x equal 1. Entonces, this is good because it split the parabola into equal parts, and we can use in symmetry. So suppose we have information about 1 point here, 1 point here. You can infer without calculation that this distance is a symmetry in the opposite direction, and you determine another point. So in this case, we have in my hand vertex, y-intercept, and 2 x-intercept. Let's switch into the Desmos to complete the graph now. I have here in Desmos. Switching. Desmos. Okay, do you see Desmos or no? Okay, this is example number 1. And example number 1. Okay, we have, look at that. Let me show you. We have the parabola. We have the parabola. We have the parabola. And we plot. Okay, this is the equation that's given. But I found vertex is 1, a. Look at that, 1, a. 0,6 is the y-intercept, is the point where the parabola crosses the y-axis. And 3,0 and negative 1,0 is this point and this point. But using my common sense and my imagination, I can see that the axis of symmetry is x equal 1. Then, let me see that. Let me see that. Okay. Then we can get another additional point here using the symmetry idea, the symmetry property is the same distance here. Entonces es obvio que si this is 1, this is 2, 2,6. Let me try. I put comma in the same color, 2,6. Bang. I have 5 points, 1, 2, 3, 4, 1, 2, 3, 4, 5. The parabola up and down. And important to say, I forgot to say, that the domain for any quadratic function is already a number. However, the range in that case is from 8 down, so from negative infinity to 8. This is the range. The range, okay, let me copy in the whiteboard this idea. Because I have no parabola in 9 and 10 and 11, no? We have the parabola from A to down. O sea, es from negative infinity to positive A, include positive A, of course. Okay, let me go. Curiosity. 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 Okay. Okay, there you go. Okay, so we have, using the idea for the symmetry, axis of symmetry, we get one additional point que was 2,6. Entonces now the domain, this is curiosity, of the function is a real number. Always is a real number. It's clear, no? Because the parabola open in both directions. There are no restrictions. We have no division, we have no square root. So the parabola is a nice function. However, the range, no. The range is no real number because the parabola exists only from negative infinity y value to a, included. Any question? Any question? Any question? No? Yes? Okay, super. No question. Okay. Remember I bring 3 examples today of the quadratic because I want to illustrate different possibility, no, of the questions. Okay, I want to raise the bar. Let's move on to the example 2. Example 2. Example 2. Example 2 is y equal 3 x squared plus 12x plus 5. Okay. In this example 2, well, this is given in standard, no in vertex form. Y I can see que A es 3, B es 12, and C is 5. Entonces, you want to determine the vertex. We can do it in different way, but in my opinion, the efficiency, super fantastic way is using that formula. It's the most important formula for now. Look, H is equal minus B over 2A. This is the formula that states the relationship between the standard, the connection between the standard and vertex form. And K, well, we can find the formula, but it's not necessary, it's complicated. Much better doing in another way I want to explain that. In order to find the vertex, suppose I want to try to find the vertex. So H is equal minus, the formula have a minus, B is 12, divided by 2 times A is 3. 2 times 3 is 6, 12 divided by 6 is 2, but actually it's negative. This is H. And what about K? Well, K is easy because K is the Y value associated with the H. So you substitution in the function, the value of the H. This is the formula. Actually, it's not a formula, but it's 1 mnemonic divided, remember that, no? Okay, so basically you evaluate 3 negative 2 squared plus 12 times negative 2 plus 5. You replace x for negative 2, is the h value, in order to find the y value que corresponding with this. Okay, entonces this is 12, no? Because it's negative 2 squared 4. This is minus 24 plus 5. The answer is, this is minus 12 plus 5 is negative 7, no? Negative 7. Negative 7. Entonces, K value is negative 7. If you want, it's a curiosity, not necessary. You express it, the vertex form, the equation, like that. Y equal, A is the same que 3, paréntesis, x minus h, pero h es negative 2. Entonces doble minus become positive. plus k, que k es 7, entonces es negativo. Actually, no plus, es minus 7. Okay, entonces this equation is equivalent to the region. Equivalent to the region. But at least we have in my hand the vertex point. Let me write here. Vertex point is located at the point -2, -7. Okay, super. Suppose I want to find out the y-intercept. Remember the formula is f of x evaluating 0. Entonces, in my opinion, the super efficiency way, you can plug in 0 here if you want. But much better, in my opinion, is plugging in 0 here. Actually, everything disappears, the answer is 5. Conclusion, guys. This is advantage and disadvantage. For finding the y-intercept, the answer is always C in standard. Okay, C in our specific example is 5. The y-intercept is the point 0.5. 0.5. For finding the x-intercept, the formula is f of x equal to 0. Now f of x equal to 0. In my opinion, the easy way to find that is using a standard. So the advantage and the x intercept and y intercept, in my opinion, is better using the standard form. However, the vertex form is more comfortable to find the vertex. So it's obvious, right? But you solving this quadratic equation. Okay. You can use it, of course, the quadratic formula, no? It's -12 plus or minus square root 12 squared -4 multiplication by 3, okay, C multiplication by 5, divided by 2 times 3. I focus it in the expression inside the parenthesis, no? Okay, I put in my calculator, no? 12 squared, 144, minus 4 times 3 is 12 times 5 is 60. Now subtraction is 84. Unfortunately, 84 is not perfect square. Okay. Entonces -12 plus or minus square root 84 divided by 6. We can simplification a little bit, but no, I want to skip that part. So I suppose I put it directly in my calculator. Okay, so you put, for example, in my calculator, I put -12 plus square root 84, divided by 6. And the answer of this is negative 0.47 and decimal approximation. This is irrational, right? Irrational because 84, let me see, 84 divided by 2, 42 divided by 2 is 21, 21 is 3 and 7. So I can see a couple of 2, so it's 2 radical, and here we have no couple 21. This is the answer, the exact answer of this radical part, no? But okay, I realize it's irrational number. So irrational number we can write. If you want to do the graph, it's much better using the decimal approximation. You put in my calculator and that's it. The -12 minus square root 84 divided by 6. The decimal approximation is -3.53. Entonces we have two x-intercept. The x-intercept of the our parabola is the point -0.47,0 and -3.53,0. Okay, so how many points I have in total right now? Well, we have a vertex, no? Yes, we have a vertex, look at that. We have the y-intercept, look at that. We have two x-intercept, similar to another problem. Entonces the rest we can use in the axial symmetry. to find the rest of the point. Also, one more point. And in this example, the axis of symmetry is x equal h, and h is -2. So we have a line, vertical line, at x equal -2. Let me try to see in Desmos the parabola. Let me try. Okay. This is example 2. Example 2. Look at that. Okay, example 2. Okay, this parabola open up. It's obvious to open up because A is 3, okay, positive. We found the vertex is at the point -2, -7. We found the weird value of the x in a set, que es -0.47,0 and -3.53,0, and we found also the y in a set, que es the point 0.5, no? Que es C value. Now you can find another extra point here. We see que it should be, in my opinion, si this distance is 2, this distance is also 2, entonces es 4, ¿no? Es 4. Es -4, comma. Okay, this distance is 2, no? And this distance in opposite direction is 2. Si this is -2, in opposite direction is -4. So it's -4,5, no? I separate by comma. -4,5. Okay, super. Okay. What about? Okay, we have the collection of the 5 points and our parabola open up. What about domain? It's always a real number. However, the range, no. The range is from -7, que is the minimum value, look, to positive infinity. This is the range. Okay, from -7 to positive. Okay, entonces let me switch again to the whiteboard. And whiteboard, let me finish the job. Look. Okay, whiteboard. Okay, there you go. Okay, so we get extra point. Remember the extra point was using the symmetry property, was -4, -5. No, +5, sorry. This is the extra. And domain or real number. And range is from -7, including -7, of course, to infinity positive. Because the parabola open up. Any question, guys? It's easy, the quadratic function. Oh no. Okay, one more example of the quadratic function. One more. I promise get the last one. Example number 3. Number 3. Example 3. Okay, this is y equal -x² plus 4x minus 5. Es obvio que this is standard. Es obvio que A es -1, B is +4, and C is -5. Okay. Si A is negative, I know que the parabola open down. So our parabola open down. So you want to find the vertex, because vertex is super important point. That you cannot do the graph of the parabola if you cannot find the vertex. It's super extremely importance number 1, vertex. Important number 2, y in a set, x in a set. By the way, let me say something about x in a set. X in a set is when you in the test number 1, when you are solving the quadratic equation, the thing we are doing in this moment was determine the real x-intercept of the one quadratic function. Now the thing we are doing in your moment in the test 1, supposedly this is a parabola, is find that point. When you solve the quadratic equation, ax squared plus bx plus c equal to 0. Okay, but now we generalize the idea now. I understand. Okay, when you find the x-intercept, the thing we are doing is put equal to 0 and solve this quadratic equation. Okay. So okay. Vertex first. Number 1, vertex. Number 2, y-intercept. Number 3, x-intercept. Okay. And additional point. And number 4, additional. Additional point using symmetry. Okay. Okay, vertex. The formula is h is equal minus b over 2a. In our specific example, b is 4, 2, and a is -1. Be careful, we have double minus, and double minus become positive. So the final answer is positive. 4 divided by 2 is 2. This is h value. In order to find the k value, you evaluate the function in 2. In other words, you replace x for 2. So minus 2 squared plus 4 times 2 minus 5. This is -4. Be careful in this calculation because -2 squared is not equivalent to -2 squared. So this stay the negative, is -4. In this case, no, it's +4. But this is not the case that we are doing now. +8 minus 5. Es -1. Es obvio que es -1, ¿no? Entonces, the vertex of the agua parábola is located at the point 2, -1. Y I know que from this point, the parabola open down. Open down. Because it's in opposite, it's negative. Okay. Let me try to find the second, is the y-intercept. It's easy. Because I know que en estándar, C is the y-intercept, que in this case is a -5. But the y-intercept es obvio que es the point 0, -5. Without do anything. X-intercept is always more complicated because I need to solve in the quadratic equation. Actually, in order to find the x-intercept, I need to solve in the quadratic equation, no? Entonces f of x in this example is minus x squared plus 4x minus 5 equal to 0. So we need to solve this quadratic equation in order to find the x-intercept. Okay? Okay, I propose you doing the quadratic formula, no? A is -1, B is +4, and C is -5. Then is minus B, que es -4, plus and minus square root 4 squared -4 multiplication by -1, que es A multiplication by -5, que es C, divided by 2 times -1. Okay, we focus in the expression inside the radical. Okay, be careful with the sign. Be careful with the sign. Look, this is 16. That's what because 16. But we have 1, 2, 3 negative. Wow, entonces es negative. And -20, no? It's -20, entonces the answer is -4. Oh. And when you try to compute the square root -4, it's imaginary, it's 2i. Entonces, that means, this is important, extremely important moment. When you try to find something in algebra, and the answer that you get is imaginary or complex, it's because in the real fields do not exist. Now, the thing that we try to find is the y-intercept do not exist, unfortunately, that this parabola never crossed the x-axis. And you can see more clear now in Desmos. Okay? Okay. Let me switch into Desmos. I plot the vertex. I plot the y-intercept. I cannot plot the x-intercept because do not exist. However, I try to find another point using the symmetry property, no? Let me try. Switch into Desmos. Okay, there you go. Desmos now, example 3. Look at that. Oh, now everything is clear now. Look. Okay, I plot the vertex, que es 2, -1. I plot that. I plot the y-intercept, que es 0, -5. Using my imagination, and I know that the axial symmetry is x = 2, this line, this distance is 2 in opposite direction, entonces 2 + 2 is 4, and another point is 4, -5. But it's obvious, guys, that if the vertex is located at the point 2, -1, and the parabola open down, never cross the x-axis. And this is the interpretation when the answer is imaginary or complex, do not exist. I repeat several times this idea. You don't know anything. However, you set out the equation to find something in algebra, and the answer is imaginary or complex. That means que do not exist. This is the interpretation. Keep in mind that we repeat this idea several times in our study. Any question in the example number 3? Do you understand very well parabola? It's confusing, it's clear. Come on, guys, opinion. Understand. Okay. I want to illustrate a little bit application of the okay. What are the potential application for the quadratic function? Suppose that you are doing something and you determine the model of this something in the real life, and the model corresponds with the parabola. So f of x is a quadratic function. In my model. Entonces, this quadratic function, when we have two possibilities, open, down, like that, or open up, like that. In the case que open, down, this point is the vertex, is a maximum. So normally in the real life, we need optimization. Optimization means in mathematics, try to find the best option. Suppose that this problem we are modeled is the maximization, the profit of my business, and the model is quadratic. So this is the thing I try is to approach it to the maximum. Another possibility is que no profit is a cost. Si ese cost is the bad guy, therefore the best option is the minimum. Okay, entonces in the problem que involve quadratic function, is super easy optimization the function using the vertex. So the vertex is extremely important point because it's the maximum or it's the minimum. Depending on the nature of the function, entonces es good maximum or it's good minimum. I bring one example. Look, example of the application, no profit, no cost, is basically geometry. Suppose that we have a parking area in Miami-Dade College is to be constructed adjacent to the road. I want to do the sketch. Application. application. Suppose we have rod like that. And the engineer, we still in this. Oh, sorry, coño. Okay, now you see whiteboard? Or not yet? Oh, let me see. Whiteboard. You see whiteboard? Okay. Okay, the thing que I explained before, que you can see, is que if I try to apply the quadratic function in the real life world problem application, and when you create a model, the model corresponding with the quadratic function, you can optimize the model or the function in the vertex, depending si es maximum or es minimum. Let's see one application. Application, for example, in that case is a parking area is to be constructed adjacent to the road. So the parking area, suppose que is like that. Okay, adjacent to the road. Okay, this is a parking area. And the engineer can develop this portion 340 feet of fencing. Okay, the perimeter. The perimeter, you see in this case, the parking garage have 3 sides, 1, 2, 3. And this side is equivalent to this. In any word problem, you immediately declare or define some variable. This side and this side is the same. And this side not necessarily the same. No? It's different. Okay, the perimeter, que es the fencing, is 240. It's a restriction for the problem. So determine the dimension. So basically, my goal is determine X and Y. Such that maximize the area. Okay, the area, maximum area. When the constraint or restriction of the fencing is 340. Okay. Entonces, in any optimization problem, guys, we have always at least 2 equations. The first equation is the objective function. The objective function is the function that involves somehow the quantity, the magnitude that I want to optimize, que es the area. And area is obvious que es X times Y, because it's a rectangle. Okay, this is the objective function. We have a constraints function, que is the restriction of our problem. Normally, it's about the amount of material that we have available to control the backing load, que is the fencing. It's 340. 340 is the constraint, is the restriction, and it's equal to X plus Y. It's the perimeter. X plus X, 2X plus Y is the perimeter. So we have equation number 1, we have equation number 2, and we manipulate with this. Okay. This don't look like similar to the quadratic function, but I try to make a substitution. For example, there are many ways to do that. I solve for y. So y is equal 340 minus 2x. And now this substitution here into the objective function, que es area. Ok, entonces area es igual x times y, que es 340, minus 2x, ¿no? I'm going to see much better. I apply this trivial property. Area is equal 340 x minus 2x squared. Something like that. Well, okay, but I don't see very well, Professor. This is, okay. My question is, come on, help me to understand this. This is a quadratic function, yes or no? This is a quadratic function, yes or no? No, yes, no. No, yes. Answer me. Is a quadratic function, yes or no? So the area we consider like a function. Okay, is a quadratic or no? Are you there? Guy, are you there? Answer me. Is quadratic function or no? Yes. How you recognize que es quadratic function? How you recognize? What is the glue que give me information que es quadratic function? Huh? Oh, okay. What is the glue que give me information que es quadratic function? What is the clue? Help me, guy. Bueno, I suppose que this is square, no? Degree 2. Very well, Andreina. Okay, let me organize the function in that way. Minus 2x squared plus 340x. And this will look like a little bit to the standard form. When A is negative 2, B is 340, and C is missing, is 0. 340, 340, 340. And remember, the optimization occur in the vertex. So the most important point in the optimization problem is the vertex. And the vertex we can find using this famous formula, que in my opinion is the most important formula today. Okay? And H is equal minus B. B in our specific problem is 340. 2 and A is negative 2. Be careful. Double minus become positive. So 340 divided by 4 is 85. Entonces, interpretation this answer. What is X? What is H? Remember, H, o sea, H, this is the vertex. By the way, our parabola, look, up and down. How do you know get up and down? Because A is negative, look. And this point is the point H comma K, que es the vertex. Entonces, the interpretation, H, normally we associate with the X component, and K we associate with the Y component. And X and Y in our problem is the dimension for the parking lot, X and Y. So it's 85 feet, I guess so. It's X. And Y, well, it's easy because I'm using the formula. What formula? That formula is 340. 340 minus 2 times 85. Because I know that X is 85. 85 times 2 minus 340 is 170 feet. Okay, this is the dimension of our parking lot. 85 feet, and 170. This is the road, no? And what about the area? Oh, the area is super easy. It's just multiplication 85, multiplication 170. And the answer is 14,450 square feet. Okay, so what is the final answer? One of the final answer, in my opinion, is the dimension. And why not the area, the total area inside contained inside this. Do you understand, guys? I suppose in the review package, I go over again to the application, some application, see you see or no in the test. I don't know exactly say put application in the test. The most important in that part we cover so far is giving the equation for the quadratic function. I don't know si es en standard or es in vertex form, and you do the graph for this and determine domain and determine range in any case. Any questions so far? Go ahead. This is the curiosity. Application is curiosity. In the test, I never put application because in the application, you need to thinking what is the equation to say we have no time to this. I go directly to the point. Okay. Any question? No? No? Okay. Let's move on to the second part of today. Is very important. Very important. Is about introduction to polynomial function. Introduction. I promise that we continue polynomial next class because it's too long topic. Okay, what is a polynomial function? Let me define definition. Polynomial is more general than quadratic, no? It's a function que have this format. Look, we have coefficiency, we have a variable raised to the n power, we have another coefficiency, x to the n minus 1, plus plus the last coefficiency I call a0, a null. Okay, this coefficiency a sub n, a sub n minus 1, a minus 2, and the last one are in general real number. And the most important is that this exponent n minus 1 and so on. So the exponent, this is the most important in the definition, are whole numbers, not real. Whole number. Whole number means 0, 1, 2, 3, So no negative. So it's totally illegal. For example, one polynomial que contain x or one function que contain no polynomial exponent -2, no polynomial. It's a contradiction with the definition of polynomial. Another que contain fraction exponent like that, 3/4, no polynomial. Okay, the polynomial that is important que is the exponent involved in the polynomial are whole number. 0, yes, because here is x to the 0. 0, 1, 2, 3, 4, 5. Maybe one element is missing, no? Pero it's okay. Okay. Entonces, an important thing after this definition is define degree. What is the degree of the polynomial? Well, the degree is the higher exponent. O sea, degree is the higher exponent of the polynomial. Higher exponent of the polynomial. Now, suppose that's example, no? F of x equal -4 x to the 5th power plus 6 x to the 4th power plus 2x. My question is it polynomial or no? Poly, yes or no? ¿Es poly o no? No? Yes? No, why no? What is the definition for the poly? Poly is que, don't confusing. The coefficiency in general, real number. Positive or negative, or fraction, or irrational, crazy. but the exponent, whole number. 5, 4, and 1. Invisible. Entonces, ¿ese polinomio o no? Yes or no? Es obvio que yes. Ajá. Complementary to this. What is the degree of this polynomial? What is the degree of this polynomial? Remember, the definition is the higher exponent. What is the degree of this polynomial? 5. Degree 5. This is a polynomial. Yes, it's a polynomial degree 5. Okay? Ajá. Entonces, polynomial is very important function that we need to know very well. Because polynomial we are using in pre-calculus and calculus, you know? Que is the next subject you need to take, calculus 1. Now, you need to keep in mind that polynomials are always continuous and smooth. So polynomial, so the graph of the polynomial always is continuous. Continuous. I want to explain what means continuous. Continuous is, without too much mathematics, is when you can do the graph of the polynomial and you write like that without lifting the pencil from the paper. So no, we have not that situation. Okay, this is discontinuous. No, never happen in polynomial function. It's smooth also, but meant to be smooth. Like this is totally smooth. So it's impossible to be something like that. This is not smooth. Okay, so we have no gap in the polynomial graphic, never. We have no hole, never. We have no asymptote. Okay, we discussing this in your moment, guy. No, now. Forget about this word. We have no corner like that because it's smooth. And we have no cups. What mean cups? Cups is like that. Chum chum. Okay, actually corner is suppose it's a line and another line is a corner. And this is no corner, this is no line, it's a curve and another curve. So the graph of the polynomial is continuous and smooth. It's super nice. Super nice. Okay. Okay. Any question? Okay. Now, to understand very well the polynomial function, I need to understand the end behavior. End behavior. End behavior. What means end behavior? So what end behavior is the y value under the supposition that x approaches to positive infinity or approaches to negative infinity in both directions. End behavior. This is the definition. Entonces, okay, do you understand end behavior? For example, you have, what is the end behavior of the classical parabola without transformation? And the family, for example, when the x to the 4 power, x to the 6 power, x to the 8 power, when the exponent is even number, when the exponent is even number, the end behavior look like that. Look, or like that. Depende, no? Depende si es positive or minus. If the coefficient is positive, open up. If the coefficient is minus, open down, no? This is the end behavior. However, the end behavior when the exponent is odd number, cubic, 3 power, 7 power, 9 power, the odd number is different. It's like that. Depende si the coefficient is positive. If the coefficient is positive, it's like that. If the coefficient is negative, it's like that. Entonces we call we call this kind of aim behavior, we call, look, the notation that we are using is, look, this is right up and left, for example, up also. Okay, this is right up, left up. Or right down and left down. Okay, this is typical for the even, no? Another possibility is right, left. When it's that like that is up, down. Is similar to this idea, no? Or this idea is left up and right down. See, this sound complicated for you. Don't worry, because you are doing the sketch like that. Yeah, I understand very well. Okay, the professor, the aim behavior of this polynomial look like that. Suppose the aim behavior of this polynomial look like that. Yeah, I understand very well. I don't care the rest. This is the aim behavior. Aim behavior. Okay. Maybe it's confused the idea. Let's see example to understand a little bit much better aim behavior. Okay, determine aim behavior. Example 1 for the polynomial aim behavior. Suppose determine aim behavior of the following polynomial. F of x is equal minus 4x to the 5th power plus 6 x to the 4th power plus 2x. Okay, by the way, was the first example we studied, no? Here to illustrate the idea for the degree. Es degree 5. Es degree 5. Entonces, what is the aim behavior? Okay, number 1 is to find the aim behavior expression. Aim behavior expression. And number 2 is graph the aim behavior. To have some idea, roughly idea, how look like the graph of this polynomial. So the aim behavior expression is just you take only the leading term, leading term, or in other words, the term can contain the higher exponent, okay? Negative 4x to the 5th power. You ignore this and this and this. Why? Why is the reason that you ignore this? Because the aim behavior, you suppose que x approach to positive or negative infinity. In other words, infinity, remember, is no number. It's a symbol que indicate que continue forever. Entonces, we can interpret que es a huge number, positive or a huge number, negative. Entonces, the dominant, the aim behavior expression is the dominant. Dominant means the term que increasing faster. Es obvio que the exponent 5 increasing faster than exponent 2 and increasing faster than exponent 1, exponent 3. In this case, we have no exponent 3, it's missing, but exponent 1. Entonces, you take always the term que increasing faster, que es exponent 5. And this is the aim behavior expression. That is the reason. It's a dominant. Dominant in infinity. And the rest no. Okay, so now I can see that when this exponent 5 que es odd number, we have two possibilities of the aim behavior. Like that, I don't care the rest, or like that. I don't care here part. That part I put here, I don't care. That depends on the coefficients. If the coefficient is negative, it's here. When the coefficient is positive, it's here. So I discard this because our example, the coefficient is negative. And this is the aim behavior. Okay. So what is the importance of that part? When you finish the graph of this, using another thing we studied after, not today, I can see the graph look like that. I don't know exactly what happened in the middle, but the end behavior approach to positive infinity and negative infinity look like that. Go down and go up in that direction. Do you understand what's confusing? It's confusing or no? Understand? Okay, let me try another example. But don't worry, because we frequently go back to this end behavior, not only in polynomial functions, in general. Let me see example 2. Example 2 now. Example 2. Suppose the function g, I want to call g. Okay, is 1/4 x, parentheses, 2x minus 3, raised to the cubic power, x plus 4, raised to the second power. Suppose it's given like that. Okay. This is confusing, I know. Pay attention, okay, it's tricky, no? I put this example to confuse you. But okay, and after when you finish, you clarify. Okay, in this previous example, okay, the polynomial is expressed in expanding form, because it's separated by plus or minus, no? In this case, no. In this case, factory form. So one possibility to find the end behavior is when you expand this, this is too long, and you take the leading coefficient, que es the coefficient que contain the higher exponent. But one fantastic way, not too long, sino short, is consider que the end behavior expression is end behavior expression. So the consideration que, remember, end behavior means que x approaches to plus and minus infinity. It's a huge number. When you plug in here, huge number, okay, million, trillion, it's obvious que this number 3 and this number 4 is completely negligible. Do not affect in the end behavior. So the expression, the end behavior expression, look like that. Expression is 1/4 is equal 1/4 state, x state. This is 2x cubic, and this is x squared. Because I remove mentally these 3 and this 4 because it's totally negligible. Do you understand this idea? And leave it like that? No. Hello. Okay, now you manipulate a little bit that part, but it's easy. It's 2 cubic is 8. 8 divided by 4 is 2. How many x in total we have? When we have 3 and 2 is 5 plus 1 is 6. And this is the end behavior expression. And we are doing too fast. We can do in the long way, you expand this multiplication 2x minus 4 3 times, foil, no good. And this is also foil, and this multiplication is too long process. However, I want to find the end behavior. And the end behavior, I don't care this number. This number is totally irrelevant. Okay, so I have a question now. What is the degree of this polynomial? In your opinion, what is the degree of this polynomial? 3, no 3. No 3. This is confusing. This is tricky because I give you the polynomial in factory form. Entonces, en factory form, somebody, not me, do the factorization. Entonces, you don't see very well what the higher exponent. You say 3 because you see these 3. But what about these 2? And what about this one? Together, no? When you expand everything, I know that the degree is 6, exactly like an aim behavior expression say. Okay. Entonces, this is the aim behavior expression. And what is the aim behavior graphic? Well, I suppose that the aim behavior graphic, because it's even, look like, and the coefficient is positive, look like that. I don't care this, like that. O sea, es like right up, left up. Guys, do you understand or is confusing this? Do you understand or is confusing this? Come on, what happened? Are you concerned about the test, no? You are focusing 100% in the test, no? And that bug is new one, you don't care what's the problem. Another example, okay, let's do it. I need another example, okay, no problem. Okay, it's obvious que another example in the, o sea, we have, okay, let me summarize the idea. We have two possibilities. Suppose we have, I give you the polynomial like that. 3x to the 4th power plus 2x to the 6th power plus x to the 3rd power plus x to the 2nd power. That's it. One possibility. This is total expanding. 4. Pero suppose not exactly this. It's suppose que I have another que es en factory form. En factory form, suppose que es x plus 3 to the 5th power, x minus 2 to the 3rd power, and x plus 5 to the 2nd power. Okay. What is the end behavior expression? End behavior expression. It's obvious que es this. I ignore this, I ignore this, I ignore this. Because 4 power is the higher exponent, I'm increasing faster to this. No, sorry, coño. Mistake, I make a mistake. What is the higher exponent? The higher exponent is this. Okay, the end behavior expression is 2x to the 6th power. I ignore this, I ignore this, and I ignore this. Because 6th power increasing faster than this. So everything is increasing. It's increasing faster than this because of QE. And it's increasing faster than QE, but it's increasing super faster. This is dominant, and this is the end behavior expression. And the graphic of the end behavior expression is 6 power, is even, the coefficient is positive, look like that. Any question? Clear or confusing? Let's see now, when it's a factory form, we can spend a lot of time to multiplication. Clear. You spend a lot of time to multiplication, x plus 3 to the 5th power. This is too long, crazy, no good. Pero you know que in the end behavior, x is infinity. So you ignore these 3, these 2, and this 5. This is nothing. My end behavior expression for G, sorry, end behavior is x to the 5th power, x to the 3rd power, x to the 2nd power. Entonces, x to the 10th power, ¿no? Because it's 3 plus 2 is 5 plus 5 is 10. This is the expression for the end behavior. O sea, when you expand this, you have long expression of the polynomial que contain 10, 9, 8, 7, 6, but I don't care. I care the dominant. What is the dominant? High exponent, degree 10. Okay? The behavior should look like similar to this because this is degree 6 and this is degree 10. But it's the same. Okay, what are the only difference? Increasing faster. So this arrow is more vertical because increasing faster than this. This is increasing, but not too fast. Clear now? A behavior expression and A behavior graphic. Clear now or no yet? Okay, Alain say yes. Okay. That's it, no? No. I need more information. Let me see a little bit more interesting example. Can include a behavior and include more points. Suppose identify no, do the graph of this polynomial function. F of x is equal x cubed plus x squared minus 9x minus 9. Okay. Question number 1. ¿Es polinomio, yes or no? Yes or no? ¿Es polinomio, yes or no? No. Why no, Alain? What is the definition of polynomial? Polynomial, remember, the most important is the exponent is a whole number. And the exponent is 3, 2, 1, and 0. The exponent here is 3, 2, 1, que es invisible, and 0, que es also invisible, no? Okay, it's a combination, linear combination of the several monomial. And the most important is, the answer is yes, it's a polynomial. Do you understand or no? Okay. This is the definition. Okay, it's a linear combination of the different monomials. And each monomial contains exponent as a whole number. Suppose que I complicate your life, I put it here 1/2. It's a polynomial. It's obvious que no, right? Okay. Okay, my next question, what is the degree of this polynomial? What is the degree? Degree is 3. Excellent. Okay. Now, my next question is, what is the aim behavior expression? Aim behavior expression. What is the dominant? What is the aim behavior expression? Remember, aim behavior is under the supposition that x is infinity positive or infinity negative. It's a huge number. 1 million, 2 million, 1 trillion. XQE, excellent. XQE is the aim behavior expression. Very well. Very well. And what is the graph of this aim behavior expression? Well, coefficient is positive. Look like that. I don't know exactly what happened here. Well, I know what happened in XQE. XQE is a function that everyone knows very well can look like that. This is X cubed. But this completely no. This is the aim behavior. Aim behavior. Exactly, I don't know exactly what happened in the middle. Is clear this idea or is confusing? Okay. But in this example, I want to do more. In this example, I want to find the 0. Identify. Clear. Okay. I want to identification the 0. So I want to find the 0. 0 means this. Remember, this is an expression okay, we're using always to find the x in a set. And why no? Y in a set is F evaluating 0. Okay, this is important point. So we need to find the X in a set and the Y in a set. Okay, let's do it. Let me start for the easy part. The easy part is the Y in a set. Always easy is Y in a set, because 0, when you evaluate 0 here, disappear that part, and stay only -9, no? -9, stay. -9. Okay, entonces when you evaluate here, the answer is -9. And the point is the point 0, -9. This is at least one point that we found. Okay, in order to find the X in a set, okay, X in a set, remember, is the solution for this equation. You copy the equation, x cubed plus x squared minus 9x minus 9. You enforce it to be 0. So it's the point in which the polynomial function crosses the x-axis. And this is the complicated part. Of course, this is super easy. That is the reason I select the first example. But I promise I want to complicate too much that part. But in this case, it's possible doing by factorization, because it's polynomial equation and sometimes happen that we can do by factorization. Okay, professor, entonces factorization is you separate 2 by 2 by grouping, no? Grouping, factorization by grouping, no? And the greatest common factor in the first couple is x squared. And the greatest common factor in the second couple is -9. Wow, fantastic. So I can see that x plus 1 is a common factor. One more time, I factor out, and it stays something like that. Okay, I suppose that everyone follow me, no? And I can see now, okay, we have differences of the square. And the factorization, okay, super. Randy is it? Yeah, I follow, professor. And the difference of a square is xx, and the square root 9 is 3 plus or minus. I suppose that you remember very well the formula a squared minus b squared is equal a plus b, a minus b. It's a difference of a square formula. Okay? Now you apply one thing, it's called a zero factor property. Zero factor property. And zero factor property is when you have several factors equal to 0, it's because 1 by 1 is equal to 0, or x plus 3 is 0, or x minus 3 is 0. Entonces, the solution of this is super easy. You separate in 3 linear equations. It's -1, is -3, is +3. So actually, we have 3 intersecting, que is the point -1,0, -3,0, and +3,0. Okay, enough of point we have. Wow. So we can do the graph of this. I don't know, see in decimal I have them. Let me see I have in decimal. Yeah, I suppose. There you go. There you go. I have in decimals. Okay, look at that, guys. Let me switch into decimals. Okay. Do you see decimals? Okay, decimals. Example. Yes. Example 1. Look at that. Example 1 is x cubed plus x squared minus 9x minus 9. Okay, let's do in the graph of this. Boom. Look at that. Okay, we have the point that we determined was 3, in this case 3. Look, 3,0, -1,0, -3,0. This is the 3x intercept. And 1 y-intercept. Okay? We have vertex. No, we have no vertex. We have a turning point, que es this. Wow, but it's weird. And another turning point here. Okay? And we have three. Three because not necessarily always it's three, but in this case, it's three. Okay? See another example. Oh, yes. Okay. Okay. Do you understand very well or no? Complicated. Oh, easy. Basically, the thing that we are doing. Wait, sorry, carajo. Now you can look at that. Again. Let me go do Desmos now. Okay, Desmos. Okay, sorry. Okay, Desmos. Okay. Do you see Desmos? Again or no? Okay. Do you see the aim behavior? Okay. Andreina, look. Do you see the aim behavior? Aim behavior is, you see from right up and to the left, down. Exactly, we predict according to the aim behavior expression. Do you understand a little bit more clear now, aim behavior? Okay, now it's a little bit confusing. Aim behavior is always confusing. Okay. Some student emailed me, I am grading a lot of tests, and a student interrupt me. Hello, what the hell? Okay. Look at the prediction. The prediction was this, aim behavior graphic. This was the prediction for aim behavior. Okay? Okay. Let me explain, so you understand very well. Let's move on to another example que es introduce new idea, no? Okay, look. It's important to understand. It's a one new concept. For example, suppose this is no example. This is theoretical part. After we see one more example, I suppose que that's it for today. Suppose we have theoretical. Suppose we have this example is x squared x minus 2 cubic, wow, and x plus 4 to the 7th power, wow. Okay. Still in Desmos. Okay. Thank you, Andreina. Still in Desmos. Okay. Suppose this. Okay. Question, ¿es polinomio o no? ¿Es polinomio o no? ¿Es poli o no? Of course, it's polynomial, right? Entonces, what is the aim behavior expression? Aim behavior expression. You remove these two mentally, these four mentally. And we have x squared, x cubic, and x7. Entonces, x12, ¿no? X12. Entonces, the degree of this polynomial is 12. Y I suppose que the aim behavior look like that. Because the coefficient es 1 que es positive. Entonces, one more important thing. Okay, and the zero. Let's focus it now. This is clear. But what about zero? Zero, remember, is equivalent to, say, x in z. So the expression is x squared, x minus 2 cubic, and x plus 4 to the 7th power. We have three zero. We have 3 0. We have add x equals 0, que es this guy, multiplicity. This is a new idea, multiplicity 2, because 2 is exponent. We have at x equal 2, this is 3, no? 3. Multiplicity 3, and x equal minus 4, multiplicity 7. Okay? Remember, the degree of our polynomial is 12. So we have x equals 0, que es 0, pero multiplicity 2. So suppose que you say, what is the solution for this equation equal to 0? Well, we have 12 solutions, no? Pero, okay. Entonces es repetition 0, 0, 2 times, because the multiplicity is 2. And 2, 2, and 2, 3 times. And negative 4, 7 times. 7 times. Okay? This is the idea for the multiplicity. And what is important? Understand the multiplicity. Oh, it's important because the graph of the polynomial, when you are doing the graph, look, we have 0, this is x-axis. We have negative 2, positive 2, sorry, 1, 2, and we have negative 4. Negative 1, negative 2, negative 3, negative 4. And negative, I know the end behavior look like that. So I know that our graph at x equal infinity positive, here at x equal negative infinity, look like that. But what's the problem? When the multiplicity is even important, this is the most important moment. When the multiplicity is even, the graph touch. Boom, like that. Of course, not like that. It's a smooth curve. Here, when the multiplicity is odd, the graph cross into. Sorry. Mistake. Okay, this is cross. Okay, this is cross. And 2 is odd. Cross. Here, touch, because it's even. Here, negative 4, again, is odd. The multiplicity is cross. Okay, cross. So it look like that. But actually, our polynomial contains 1, 2, and 3, 0. However, when the multiplicity is even, the graph touch the axis and not cross it. When the multiplicity is odd, cross it. So this is the roughly sketch how look like the graph of this polynomial. Okay, entonces summarize. Si the multiplicity is even number, touch. Si the multiplicity is odd number, cross. The x-axis. X-axis. Okay. Let me go to the more complete. This is theoretical. Let me apply this new theoretical idea in the example 2. Example 2. Example 2, we are doing everything we studied so far in the polynomial, no? It's not too much. We continue next time doing that part. Suppose f of x is equal x to the 4th power minus 4x to the second power. Suppose que given this expression. My question is polynomial, yes or no? Poly, yes or no? Yes or no? Yes. Because the exponent is whole number. What is the degree of this polynomial? What is the degree? What is the degree? What is the degree? What is the degree? Randy, what is the degree, Randy? Yes, 4. Align say 4 degree, professor. Okay. What is the n behavior expression? N behavior expression. And this is easy because it's expanding form, no factor form. What is the n behavior expression? Huh? Exactly, x to the 4th power. And what is the n behavior graph? N behavior graph. N behavior graph look like that. Okay, right up, left up, because it's even. Okay, this is importance of the n behavior expression and graph. Okay, that's it. No, let's find the zero. Let's find the zero. Well, let's find everything. Let's find the y-intercept and x-intercept, the zeros. So is to find the y-intercept, you evaluate the function as 0. Eso because 0, because 0 to the 4th power minus 4 times 0 is 0. 0 is equal to 0, and the point 0, 0 belong to the our function. 0, 0 is both. It's x and y-intercept. To find the y-intercept, you enforce the y value to be 0. So the formula is f of x equal to 0. In other words, you write x to the 4th power minus 4x to the 2nd power equal to 0. And you have this equation. Okay, in this case, let's do it by factorization. Okay, factorization is easy way, but factorization is weak. Next class, we study another way to find the 0 more strong. No, not totally strong. We need to complementary with another theorem to find the 0 of the polynomial. This is a challenge. This is a challenge. Find the 0 of the polynomial. Okay, but don't worry for now. Now, factorization, the greatest common factor is x squared minus 4. And we apply now again the differences of the square. So the factorization is x squared, open 2 parentheses, x 2 plus and minus equal to 0. Entonces you apply one more time the zero factor property. Entonces x equals 0, que es the first part. So actually it's x squared equals 0, ¿no? Que es equivalent to say x equals 0, pero multiplicity 2. Because the exponent is 2. So actually we have 2 zeros, 0, 0. But you write only one time. And the rest is x plus 2 equals 0. It's negative 2. X equals minus 2, multiplicity 1. And x equals positive 2, multiplicity 1 again. Okay? 1 plus 1 is 2, plus 2 is 4, get equal the degree. So the sum of the multiplicity is equal to the degree. Okay, now I know okay, our n behavior look like that. Look, graphic. I know okay, this 0, the graph touch, because the multiplicity is even, and it's cross. Let me try to do by hand a roughly sketch, and after we can see in decimal, no? Of our polynomial graphic. Okay, look. This is my sketch. X, Y. Okay, we have 0,0 is important point because it's x in a set and y in a set both. 1, 2, this is 2, this is 0, and -2. Okay, I know that the A behavior look like that. Okay, and 2 cross. Well, let me using another color to see much better. Cross. Here, touch, and here cross. And so you have a roughly idea how it look like the graph of this polynomial function. Now, I suppose that you understand much better now what is the importance of the end behavior. So far, the only thing we studied in this lecture was definition for the polynomial. Remember, you immediately recognize que ese polynomial when the exponent is a whole number. If the exponent is negative or is a fraction, no polynomial. Secondly, the degree is the higher exponent. Number 2, end behavior. End behavior is the dominant. Okay, is when the x approaches to infinity positive, infinity negative. The supposition is that x is a huge number in both directions. What is the behavior of the graph? And to understand the behavior, you take the dominant expression. And to find the zero, so far, we are doing by factorization. I promise in the last class, the next class, we study another more efficiency way to find the zero. Another theorem que complementa la idea for the zero. And so the most important thing is okay, we have different kind of zero. When the multiplicity is even, touch, like that. When the multiplicity is odd, cross the axis. Cross the axis and touch the axis. Okay? Clear or confusing? Randy, everything okay? Align, everything okay? Clear. Okay. Entonces, one complementary idea, complementary, the last one. I promise it's the last one. It's the last one. What about, he said, K, what about K? Meeting with K. Oh, everything is okay. Align, okay. Look, one complementary idea. What about the turning point? Turning point. What means turning point? Well, turning point is look like a vertex, not turning point. Es obvio que in the parabola we have only one. So turning point is equal vertex in the parabola when the degree is equal to, no? Let me see what happened. Let me see what happened. Let me see what happened. Different polynomial, no? Actually, the quadratic function that we studied today is a particular example of the polynomial degree 2, no? Degree equal to ese parábola, one have only one turning point. Degree 2 turning point equal one turning point. Degree 3 look like that. We have two turning points, 1 and 2. Turning point equal to. Degree 4, we have maybe like that. Look at the end behavior. Is up, left and right. In this case, is right up, left down. In this case, is when it's even, it's like that. Even. Look, turning point is 3, no? 1, 2, 3. Turning point equal 3. Entonces, suppose que the turning point is one number less than the degree. So 4 minus 1 is 3, 3 minus 2 minus 1 is 2, and 2 minus 1 is 1. No, pero not always. Entonces, what is the idea? Because we have some particular case. For example, the elementary cube function. Que you know que the graph, look like that. No, sorry. Look like that. Entonces, we have no turning point. Turning point, 0. Entonces, what is the idea? What is the idea for the turning point? The idea is que the turning point, the amount of the turning point is at most n minus 1. And n represents the degree. Okay, degree minus 1. Let me write in more proper way. The degree minus 1. Okay, entonces this is no super general. Is a clue que give me information. So you have degree 3. The majority, the maximum value of the turning point is 2. Maybe in this case, a degree 3, we have no turning point. Maybe 0, maybe 1, maybe 2, or maybe 3. Impossible to be 4 turning point in degree 3. Do you understand the last idea? It's the last because yeah, I want to finish now. I want to finish. Any question, guys? The most important, don't forget to send me the test. Send me the test on paper because I want to grade tomorrow and submit the Alex test. Remember, I give you 10 extra points so you complete the homework, but the homework for 80% both. Okay? And 10 extra points. And 5 extra points if you subscribe my YouTube channel, no? That's it. You try to do your best, guys. Any problem, you communicate with me by email. So any particular situation, because I know that some students have family problems with the pandemic. Okay, no. Okay, you communicate with me. No, in the lecture, of course, we have limited time. Any situation, suppose you have one mistake, Alex. Yeah, one guy fix it. I can fix it, but when you have right, no? Okay? Okay, guys. Homework, pero homework en Alex. Homework en Alex, okay? Thank you. Always is a pleasure to work with you.